Okay, once again, welcome to class. Today, we'll be looking at the basis of probability. We'll be looking at the basis of probability. And we'll be starting with the concept of definition. So, the question here is, what is probability? So, probability can simply be defined as a measure. These are keywords. As a measure of the degree of likelihood of an event happening. It is the measure of the degree of the likelihood of an event happening. That is what we call probability. What that means is that because we are in a world that is full of uncertainty, there is a need for us to study for the probability or the likelihood that an event is going to happen. So imagine a straight line where we have a 0 at one end and 1 at the other end. When this is 0, let's target impossible or impossibility, and let's tag this one certainty. Certainty. Certainty or certain. In between this impossibility and certainty is what we call probability. You understand? So the moment we are not sure of either an event is impossible or either an event is sure, then we are left with calculating for the probability of that event. So, like I just defined earlier, that probability can simply be defined as a measure of the degree of likelihood of an event happening. So, classically or traditionally, the formula for probability of a probability is denoted by PR. Some says PR and some simply use P. So we can say that probability of an event, let us say event X, is equals to the number of required outcome all over total number of outcome. All over total number of what? Of outcome. That is what we simply call probability. So in a simple term, making use of variables, we can simply say that the probability of variable X or an event X is the required outcome all over the total outcome of the given event T. Because some even use R over N depending on what you are looking at. So the variable denotation does not really matter, as it were. You understand? So if for instance, let's just take a simple example. You are asked to solve for the probability of getting a head when you toss a coin. Solve for the probability of getting a head when you toss a coin. You know that from sample space, when you toss a coin, it's either you have a head or a tail, and that is literally how many outcomes? 2 outcomes, meaning that the cardinality of the sample space is simply 2. That is n of 2. N of sample space is equal to 2. Do you understand? So the probability of getting a head is simply the required head, how many head are there, over the total number of the outcome, and that is simply 1 over 2. Do you understand? And for tail as well is 1 over 2. That's what we mean. And if, for instance, you are asked to solve for the probability of getting, let us say, for instance, this is another example, that you toss a die, or let me say you throw a die, and solve for the probability of getting 1 when a die is thrown. You know that when you throw a die, the sample space is what? 1, 2, 3, 4, 5, and 6. So that is what is the cardinality of that sample space. How many outcomes are there? We simply have how many outcomes? 6 outcomes are there. So required outcome, which is 1. How many 1 do we have in this sample space? We simply have just 1 1. So probability of getting a 1 is simply what? 1 over 6, and that is because the number of R is 1 and the other number is what? Is 6. Do you understand that? So what if they say we should solve for the probability of getting an even number? Probability of getting an even number. Then we can tag that one an event space E1. So probability of getting an even number will have been what? 2, 4, and 6. These are even number. And the cardinality of that event space is simply what? 3. You understand? So the probability of getting even number, that means probability of getting event E1, which is even number, is equals to the required number of event E1 all over the total number, and that is simply equals to 3 over 6. You understand? When you slice it out, you have 1 over 2. So that is the probability. Same thing goes for when you're looking for odd number, or if you are asked that when you throw that die, you are going to have a prime number. You understand? If I'm looking for a prime number, let me say I denote that with event A. Getting a prime number is either it shows 2, 3, or 5. Is that not true? So that means the cardinality of my event A, which is an event space that shows the outcome of prime numbers, that's simply 3. So probability of getting this my event A is simply equals to the cardinality and the required number of that event A all over what? The total sample space, the total entity in the sample space, which is equals to 3 over what? Over 6 as well. And that will give us 1 over 2. So these are just the simple stuff I believe that we should know as it were. And before I proceed, I would like to I hope it's not too early in the class to let you know that, let me just go this route, let you know that in probability, when you see the word or, it simply means we are adding up. We're going to be adding maybe outcomes. And when you see the word and, it means multiplication. Do you get that? That is what it implies. So let me give you an instance. From the last question I just treated, you throw in a die, which your sample space is 1, 2, 3, 4, 5, 6. Do you understand? What if you are asked that what is the probability that when you throw a die is either showing a 3 or a 4? Either is showing a 3 or a 4. So probability that is showing a 3 or is showing a 4 is simply equal to probability that it shows 3 or, which is plus, it shows a 4, which will then become what? How many 3 can you see in that sample space? Don't forget it's 1, 2, 3, 4, 5, then 6. So how many 3 can you see here? Definitely you can only see how many? You can only see 1 of the 3. So that is 1 over 6 plus how many 4 can you see there? Also 1 over 6. And that will give you what? 2 over 6, which equals to 1 over what? 1 over 3. And that is easy peasy, bar. It's quite easy to deal with. So having done that, we can then take a step further. Now, logarithm has laws, just like indices has laws. Surd has rules. Yes, but something that is peculiar to probability is that probability has what we call axioms. Do you understand? Probability has what we call axioms. Yes, probability has what we call axioms. So what we call axioms of probability. Do you understand? So I'm going to state about the basic 4 axioms that I believe you should know. I'll list them out for you to look at. Then, what are the axioms? The first axiom is called the non-negative axiom, or non-negativity, anyone you want. Negativity. It simply means that probability can never be negative. Probability can never be negative. That means the probability of any event, say X, can never be negative. It is always greater than 0. It is positive. Or, yes, it's positive. So it's greater than 0. That's the first thing that must be noted. Probability cannot be negative. The second of it is called the boundedness property. The boundedness property. The boundedness. Now, what do we say about the boundedness? Is that the probability of an event is hinge between 0 and 1. That is to say that the probability of the event x cannot be greater than 1 and cannot be less than 0. So the best probability can go, the highest it can go is 1, and the least it can go is 0. And I just said it from video of the video that 0 simplify a possibility, and that's just my way of trying to explain it to you better. 1 simply means it's certain, it's sure. Do you understand that? So it's between 0 and 1. So probability can pick up infinite number between 0 and 1. It can be 0.1, 0.11, 0.111, 0.9, 0.95, 0.9, but never will it be -2 or -1, or never will it be 1.2, 1.3. It's only the corridor of its operation is between 0 and 1. So the next one we have, which is number 3 of it, is that I call it the excursive. I call that excursive property, meaning that when you add up, if I have a sample space, let me say a sample space, x1, x2, x3, all the way down to xn. This is all the sample space. When I add up the probability of all of the events in that sample space, all of them will add up to 1. What does that imply? It means that with respect to this sample space, the probability of event x1 plus probability of event x2 plus probability of event x3 all the way down to probability of event xn will equals 1. Yes, that is called excursive property. And if you take, for instance, the first example I took, when you toss a coin, which can either show a head or a tail, probability that it shows a head is 1/2, plus probability that it shows a tail is 1/2. When you add it up, it give you 1. Do the same for the coin too. You also have 1. So lastly is the success and failure axioms. In probability, success does not mean the person succeeded or something succeeded. It simply means it happens. Success means that an event happened. Do you understand? Why failure simply means it did not happen. So success is denoted by P and failure is denoted by Q. So with respect to the event, we can say P of X and Q of X. So what we are saying is that the probability that an event will happen plus the probability that an event will not happen will eventually become 1. That is what I'm trying to say. So for instance, if we say that the probability that an event will happen is, let us say that it is 0.1, it's going to happen. That is the success. So what will be the probability that it's not going to happen? Q of X. It will simply equals to 1 minus 0.1, which equals to 0.9. That is called the success and plus failures axiom. Do you understand? So if the probability that an event will happen is 0.7, the probability that it's not going to happen is 0.3. So they are complementary in the sense of becoming 1. Do you get what I'm trying to say? So adding both will always give you 1. So the probability that I'm going to obtain an event from an experiment is 1/5. Then the probability that I'm not going to obtain it is 4/5. So it's just that simple. So that is what I want us to know for this class, at least the basis, the definition, down to the basic formula that accomplishes it, then to the simple examples with respect to sample space, then the axioms. So kindly go through this, and in the next class we'll look at something more deeper. Thank you for being a part of the class.